Hi, I'm Michael, a PhD student at UC Santa Barbara, and this is work with my co-authors Yiran, Sharon, Chitta, Yezhou, and William called Lost in Translation: Translation Errors and Challenges for Fair Assessment of Text-to-Image Models on Multilingual Concepts. Okay, so to start off, I should probably explain what I mean by multilingual assessment in text-to-image models. In my prior work from ACL 2023, we assessed how well text-to-image models could generate consistent images given the same concept but prompted in different languages. So in this example, we prompt for an airplane, a photo of an airplane, un foto de un avión, or hikoki no shashin, which is asking for that same thing in English, Spanish, and Japanese. Then some model that we're evaluating will generate a set of images as an output population, and then we can test the pairwise cosine similarity of some embedding models' visual features between those populations to assess whether the model is correctly possessing that concept in those test languages. We call this feature XC. We scale up this test using an automated translation process because we want to test languages that I don't speak. So we produce a list of 193 tangible concepts in 7 test languages: Spanish, German, Chinese, Japanese, Hebrew, and Indonesian. What we do is we take a source list of tangible nouns that we expect to be well represented in all of them. We use an ensemble of commercial translators to produce candidate translations, which we then use a multilingual knowledge graph called BabelNet as a consensus mechanism to get our candidate translation list. This gives us these features for concept correctness that can be organized as histograms. Here we're looking at the histograms for 6 different text-to-image models for those languages. More rightward mass will represent more concepts being known by the model, and more leftward mass will represent fewer concepts being possessed. So, for an example, we can look at the concept of airplane, and here we see that DALL-E 2 does indeed possess the concept of airplane in Chinese, but Stable Diffusion 2 does not possess the concept of airplane. Indeed, we can verify that these features are representative of the thing we're trying to measure by sampling from the right side of those histograms. So we can see that far rightward concepts on those plots, such as rabbit in Spanish, snow in Japanese, and guitar in Indonesian, are correctly generated by Stable Diffusion 2, validating that this automated feature does give us a good sense of whether a concept is correctly possessed. Unfortunately, upon manual inspection, we found that this automated translation process led to some translation errors. Through manual analysis by competent speakers of Spanish, Chinese, and Japanese, we were able to find that 4.7% of the concepts in Spanish, 8.8% of them in Chinese, and 12.9% of them in Japanese had some kind of candidate translation error. So on the top here we see the concept of bike translated into Japanese. The original sense that was produced by this automated pipeline corresponded more to the sense of a motorbike, whereas most English speakers will have a bicycle as their prototypical representation in their mind. And indeed we see that the English images are of bicycles, but the first generated one is of a motorcycle, while after we apply this translation, the 2 languages are now in agreement. Similarly, in Chinese, suit was originally translated into an adjectival form that was more meaning suitable or fitting. But when we apply the correction to mean the tangible sense that it means in English, we find that there is a correct generated image now. So in both of these examples, these mistranslations within the benchmark was causing false negatives that we could fix by applying this more faithful translation. So in essence, the purpose of this work is to try to identify when do these translation errors matter and which ones matter, so that we can better understand that we're fairly testing these text-to-image models in terms of their multilingual performance. To do this, we introduce a measure of text domain mistranslation severity that we call delta sem. Basically, the way that this works is we take the original candidate translation in its language, and then we take the correction candidate, and then we assess the distances between the original translation and the translation candidate to the English language original word in a multilingual embedding space. We see in this example that the difference between the aforementioned motorbike sense of bike in Japanese and bicycle sense of bike in Japanese are not that far apart. So this is a small difference in this delta sem feature. Whereas There are more severe translation errors, such as translating table into Chinese as tabular form rather than table that you set things on, and we find that in this multilingual embedding space, the original translation is much further away from the English term than the corrected one. This represents a large delta sem. We're able to analyze the relationship between this delta sem feature and the different types of errors. So among the errors that we manually enumerated, we found that there were formality errors, such as translating a word like dad to daddy rather than father. Commonality errors, such as picking a more rare form of a word, but a translation that's technically correct. Ambiguity and transliteration errors, which mostly deal with collisions. And then sense errors, such as translating rock to mean rock music rather than a stone. We find that some error types, in particular sense, ambiguity, and transliteration, are much more severe than those commonality and formality translation errors, as depicted by these histograms. So the question that remains is this: does our translation correction severity feature, delta sem, predict the improvement that we'll find under those translation improvements in our image domain assessment of text-to-image model concept possession? We test this by comparing that delta sem feature to what we call delta xc, which is the change in that image domain CoCo-CroLa correctness score under the translation change. We find that delta sem here on the x-axis in these plots is indeed correlated to improvement in the correctness score for Spanish for Stable Diffusion 2.1. But we find that this is not the case for Stable Diffusion 2.1 in Chinese and Japanese. So why could that be? Well, we think that the model's overall knowledge of Spanish, Chinese, and Japanese is the explanatory factor here. We see that in this regime of what we call possession of a concept, basically just having that XC CoCo-CroLa correctness score being above some arbitrary threshold, here it's 0.4, for both Stable Diffusion 2 and Alt Diffusion, there's a significant amount of mass of these concepts in Spanish that fall above that possession line. However, for Chinese and Japanese, very few of them fall over that possession line for Stable Diffusion 2, whereas many of them, almost the same amount as there are in Spanish, fall to the right of that line for Alt Diffusion, the model here on the right. And indeed, when we look at this same relationship between delta sem and delta xc, we do find that since the model knows Japanese, Chinese, and Spanish, it is indeed the case that this text domain measure of the mistranslation severity is actually predictive of how many false negatives will be driven by that translation error. So here's a couple of subjective examples. So here we have the term tent in English and the term table in English. And we're looking at the Spanish translations of tent and the Chinese translations of table. So here we go from tent to the Spanish language word tienda. And this does relate to tents in general, but it also has this sense that is more predominant that is referring to a shop or a store. This can be corrected to the more specific term tienda de acampar to refer specifically to a tent that you camp in. But we see here that for Stable Diffusion 1.4 and Stable Diffusion 2, making that correction does not actually improve the model's performance. It's generating the same images as before, and these would be scored as non-possession. Similarly here, for table, the original translation was with respect to a tabular form. We corrected it to the term that means table, and we find no improvement for Stable Diffusion 1.4 and Stable Diffusion 2. But when we go to look at Stable Diffusion 2.1 and Alt Diffusion, we find that for this model that has the best performance in the multilingual setting, Alt Diffusion, both of these false negatives that were originally assessed are fixed by applying this translation correction. So what does this mean overall? First of all, the translation of these single word concepts really represents a novel domain for machine translation. We were able to include these manual corrections into a new release of the CoCo-CroLa benchmark that doesn't suffer from these same mistranslation errors. But as we are not speakers of Hebrew or Indonesian, we're not able to give the benchmark this same attention to apply those corrections. And really, we want a robust process that can produce an automated set so that we can expand this probe into the multilingual capabilities of these generative models even further. So the question is, how do we fix this? It's a problem because translating a single sense term of a specific word is pretty far out of the distribution of how machine translation models are trained. And we think one potential way to fix this issue would be to first generate complex sentences that contain less ambiguity. So instead of just trying to translate table, we could translate something like a book sitting on a table. There's less ambiguity there with respect to what sense we are referring to table in. So perhaps by first generating these more concrete and complex sentences with less ambiguity, we could then extract the correct translations using an LLM or something. We're experimenting with that going forward. But also, we have this even more inherent difficulty here, which is, how can we really assess parallel concept knowledge between languages when some concepts are just not fully translatable? And this opens up, I think, some very interesting directions for future work. Like, what are the limits to multilinguality assessment when not all concepts can be parallel translatable? How do we handle the fact that prototypical concepts vary a lot between languages when we're building some broader assessment process of multilinguality? And are there ways to assess multilingual knowledge that don't require this strict sense agreement and strict translatability as CoCo-CroLa does? I think all of these are interesting, and I would love to see future work on this topic. So thank you for watching this talk. You can contact me or my co-author Yiran at these emails below. And yeah, thanks for watching.